Steganography. What is steganography? Steganography is the process of hiding messages inside another message or file in such a way that only the sender and the receiver is aware that something is hidden. Steganography comes from the Greek words stegnos, which means covered, and graphy, which means writing. Cryptography versus steganography. Lots of people tend to confuse cryptography and steganography, so we'll clear that up first. In cryptography, we encrypt the data, and when the attacker simply looks at the file, he knows that something is hidden within it. But in steganography, it is impossible to tell whether something is hidden or not just by simply looking at the file. So let's look at some examples in history about steganography. In 499 BC, the king of Persia, what he used to do was, he used to shave the head of his messenger, write a secret message, and wait for the hair to grow back. And then he sends the messenger to the person he wants to send the message to. And the person on the other end, what he'll do is, he'll shave the hair again and look at the secret message. Another example was the king of Sparta. What he used to do was, he used to have a wax tablet, and he wrote his message inside the wax tablet, and he covered that tablet again with a layer of beeswax, and then wrote another message on top of it. The message on top was not of much importance, and when the message reaches the other side, the person would remove the small layer of beeswax and see the hidden message in the wax tablet. So this is what steganography looks like. You have your carrier file and you have your carrier file with the message, and you can't see any visible difference in the files. So what can be used as a carrier file? A text file can be used as a carrier file, an image file can be used, an audio file, or also a video file. Any sort of file can be used as a carrier file. So what is null cipher? A null cipher is a simple text-based steganography method in which the secret message is formed by taking the first or any other position letter of each word in the cover message. So we see an example of a null cipher. So you can see this is the cover message, and you can see that saying President's embargo ruling should have immediate notice, grave situation affecting international law. Statement foreshadows ruin of many neutrals, yellow journals unifying national excitement immensely. So it doesn't make much sense, but you can't see any messages in it. But suppose you take the first letter in each word. You take P, E, R, S, H, I, N, G, S, A, I, L, S, F, R, O, M, N, Y, J, U, N, E, I. So you can see that it's saying perishing sales from New York, June 1st. So this way you can get the hidden messages. This is an example of a null cipher. Let's look at image steganography. First, before looking at the image steganography, we'll see how images store their data. So in order to have a 22-bit color representation, you have your three colors, which is red, green and blue. Every single color can be a combination of red, green and blue. So for this green, you can see that this color over here, there is the R value is 0, the G value is 129 and the B value is 2. R is red, G is green and blue is B. So if you look at the binary representation of 0 and 129 and 2, you can see that red is all zeros and green is 1 0 0 0 0 0 0 1 and blue is 0 0 0 0 0 0 1 0. And let's look at how steganography can be done with this. So we look at modifying the significant bit of a pixel. So here is the original color over here, which is 0, 129 and 2, and you can see that the last significant bit over here is 0, 1 and 0. What steganography does is, it will replace the text over here. So instead of 0 it will be 1, and instead of 1 it will be 0, and instead of 0 again it will be 1. And you can see that the RGB values have changed very little over here. You can see that R is now 1 and G is 128 and B is 3. And you can see it's different from here, but if you look at the colors, you can't see much of a difference because it's a very small difference between them. So this way you can do image steganography. So how do you substitute the last bit? So suppose I want to hide the secret data 3. What I'm going to do is, I'm going to take the original over here, which is 1, 128 and 2 over here, which is, and the last significant bits are 1, 0, 0. So I'm going to hide the message 3 along with this. So we can see that I have changed it over here from 1 to 0, and from 0 to 1, and from again 0 to 1. And 0, 1, 1, if you convert it back to a integer, it will be 3. So that way I have hidden the message 3 using the binary representation 0, 1, 1. So this is what image steganography is. There is no difference between the two images. So now let's look at audio steganography. So methods used for audio steganography is LSB coding, parity coding, phase coding, spread spectrum, and echo hiding. So LSB coding is the same as what we encountered in image steganography. The secret data is hidden in the last byte. And let's look at some steganography tools. Some steganography tools are OpenStegno, BMP Secrets, OpenPuff, StegnoG, Steganographic Laboratory, MP3 Stegno, and much more. So now we'll cover the practical demonstration of steganography.